Welcome to Math 1314. This is section 1.4. In this section, we're solving equations, but the equations are different now. Different in the following way. If you look at question 1 here, this problem has the variable being squared. That adds a whole new layer of complexity to our situation. And so the techniques we're going to use go from easy to more complex and longer. So let's go slowly. Let's see how well we do here. In this very first question, they want us to solve this by something called the zero product property. What does that mean? Well, the zero product property says if I have a product of two items is equal to 0. The only way that can happen is if one of them or both of them is actually 0. Now again, the important part is the product must be equal to 0 to be able to make that conclusion. So when you look at our problem, there is no 0 on the right hand side. So I simply move the 24 to the left. Alright, that does give me this 0 on the right hand side. And now the question is, can I take this item, which has 3 terms, and factor it into a product of 2 items that would give me 0? So let's see. When I factor it, I'm looking for 4 things. The first item times the first item has to be the m squared. Well, that's pretty easy here. That's just m and m. Now, the last 2 items, when I multiply them together, must give me this minus 24. But there's more to it than just that. Because when I combine the inside here and the outside, I have to have them add up to give me 5m. So let's see. Product of 2 things is 24. That could be 24 and 1, 12 and 2, 8 and 3, 6 and 4. All of those possibilities. But remember, I need somehow to have the middle and the outside give me 5. Well, 24 plus or minus 1 is never going to give me 5. 12 plus or minus 2 won't give me 5. But with this 8 and 3, if I could have 8 minus 3, I would get the 5. So let's see, make this a plus 8, this a minus 3. Minus 3 times 8 is this minus 24. And from the middle I get a minus 3m. From the outside I get a 8m, and so that does give me the 5m. So from there it's easy. I grab each part, set it equal to 0, and then solve for m. So I get answers of m is 3 and m is minus 8. So here we have 2 solutions, which is common when I have a squared term. We can get 2 answers, 1 answer, or we'll see 2 complex number answers. All right, question 2. Question 2, we have 2n squared equals 18n. Again, I can only use this zero product property if I have it equal to 0. So I'm going to move the 18n to the left. So now, unlike the last problem, I only have 2 terms here. So I'm not going to have it as a product looking for 4 items. What I'm looking for here is there anything in common between 2n squared and 18n? Well, yes, a 2n, because 2n times n is 2n squared. 2n times this minus 9 is a minus 18n. So, grab each piece, set it equal to 0. 2n is 0. Divide things by 2, and so I get one answer is 0. I mean, 0 is a legitimate answer. N minus 9 is 0. I get n is 9. So again, two solutions. Now in question 3, we have our problem here. Now we feel really happy at first because it's already factored for us, and I don't have to spend time factoring it. But the problem is the right hand side is not 0. And to use the zero product property, I need a product to be 0. So rather than factoring, I need to multiply it back out, combine everything, get the 36 over to the left. So let's see, m times m squared, I get a 6m, I get a minus 7m, I get a minus 42. So there's 4 things I've got to multiply all together. And now I'm going to bring over the 36. Let's see, a minus 7m and a 6m, that's a minus 1m. A minus 42 and a 36 is a minus 6. And so finally we're down to the place we need. It has 3 terms, so I'm looking for a product and I'm trying to fill in 4 numbers. Let's see, m times m is the m squared. I need a product of 2 numbers to give me 6, yet the inside and outside must add to give me this minus 1. Well, luckily with the 6, we don't have a lot of choices. It's 6 and 1 or 2 and 3. Well, the only way I can get a minus 1 is if I have a minus 3 and a plus 2. That would give me the minus m. So, grab each piece, set them equal to 0, move the plus 2, move the minus 3, and we get as answers minus 2 and 3. So again, when I have this 0 product property, I have to have a 0 on the right hand side. Alright, question 4. Question 4 says they want us to use something new, something called the square root property. Now what does the square root property say? It says if I can write my problem as something squared equals a number, then I can conclude I get the something back without the squaring, equal to plus or minus the square root of the number. So I have to be able to recognize my problem as something squared equals a number. So let's see. Well, look, something squared equals a number, and so I can already conclude my answer is y is plus or minus the square root of 36, and the square root of 36 is 6. So not too bad. Again, I have to see it as something squared, the whole side squared. Now, sometimes you hear students say, oh, just take the square root of both sides. Well, that's not what's really going on. You see, if I moved the 36 to the left, I'd factor this into y is plus 6, y minus 6, giving me solutions of minus 6 and 6, leading me to conclude the answer is plus or minus 6. So it really comes from factoring. What the square root property does is it shortcuts the process of factoring. In that, I can jump from the squared directly to the thing without the square. All right, question 5. Now in question 5, we, remember, need something squared. Well, there's this 28 in the way, so I need to move it to the right. All right, now that's better. 7w squared is minus 28. But that's not the whole side squared. That's just the w squared. So I divide both sides by 7. Minus 28 over 7 is minus 4. And so by the square root property, I get w is plus or minus the square root of minus 4. Well, let's talk about that. Square root of minus 4 is 4 times minus 1, all under the square root. I can split the square root into each of them separately. Square root of 4 is 2. Now this thing, this square root of minus 1, is not a real number. We have agreed to call this thing I, which is a complex number. Now that's really all we have to remember about complex numbers, is they come about when I have a square root of a negative number. So just split off the minus part, and that part gives you the I. So square root of minus 4 is 2i. So we get two complex numbers as our answer, which is plus or minus 2i. All right, question 6. Well, question 6 is all set up for us. I do have something squared is equal to a number. There's nothing I need to do. So I can conclude w minus l is plus or minus the square root of 36, and that's just 6. So now move the 11 to the right, and w is 11 plus or minus 6. So one answer is I use the plus. 11 plus 6 is 17. And the second answer, I use the minus. 11 minus 6 is 5. So our solution set has two numbers, 5 and 17. Question 7, things get complicated. We want to take our problem and we want to solve it by a technique called completing the square. Now, completing the square is long and terrifying, so let's not get lost in the process. The whole idea is to take our problem, transform it into something squared equals a number. Now, why is that a good thing? Well, that's a good thing because if I can do that, I can solve this using the thing we just did, which is the square root property. So the process goes like the following. First part is a equal to 1? A, where's A? I don't see any A in there. Well, if you go back to the standard form, which looks like A, the thing squared, plus B times our variable, plus C equals 0, the A is the number that's in front of the squared part. And yes, that is 1. So since it's 1, I don't have to do anything and I can go to step 2. If the lead term were not 1, I would have to divide each piece by a, whatever that is, to make it a 1. All right, so step 2. I want to move the c, where's the c? It's the number, to the right-hand side. It's going to get in the way, so just move it to the right. It's a -3. It now becomes a +3. Question 3 is part 3 here is where all of the important parts are coming up. I need b. What's b? B is the number in front of the variable. I need to calculate b over 2, or if it happens to be easier, 1/2 times b. These are the same thing, but if b is a fraction, it turns out the second one is easier to do. So let's see. b is 18. 18 divided by 2 is 9. And I'm going to save that number because I'm going to need it in a little bit for factoring. I take that number, the 9, and I square it. Well, let's see, 9 squared is 81, and I'm saving that for adding. So 2 numbers, an adding number and a factoring number. In step 4, I take my adding number and I'm going to add it to both sides. So there it is, there it is. Now I want to combine the right hand side, so 3 and 81 is 84. Alright. And the left hand side will always, again, always factor in the following way. Something squared, where all you have to do is fill in the factoring number along with its sign that you saved. So in our case, something squared, variable is m. The factoring number, remember, was 9. It's a +9. And so fill that in to the problem. But now I can solve this using the square root property. And so I get m plus 9 is plus or minus the square root of 84. Now, the question is, can I simplify this? This square root 84. What I'm wondering is, can I write this? Let me get rid of the square root. What I'm wondering is the following. Here's 84. I'm wondering, can I write this as 4 times something, or 9 times something, or 16 times something, or 25 times something? Why am I looking for that? Well, because each of these numbers I know the square root of. And so if I can split my 84 into some things I know the square root of, I can simplify the radical. And so in this case, it is 4 times 21. Square root of 4 is 2. So moving the 9, I get minus 9 plus or minus 2 square root 21. So again, when you're trying to break down the thing under the radical, just ask yourself, is it writable as a product of a square that you know? So just go step by step. Try the 4, try the 9, try the 16, try the 25. The next one would be 36 times something, and so on. Alright, yes, it is complicated, but we're surviving. So let's see. Question 8. In question 8, well, let's see. They want us to solve this again by completing the square. Is the lead term a 1? Yes, the thing in the front here is a 1. I would normally move the c, but it's already moved. So some of the work is done for us. So we're already at step 3. I need b. b is minus 6. b divided by 2 is minus 6 over 2, which is minus 3. And so that's my factor number. And I'm going to take it with its sign when I need it. Minus 3 squared is 9. That's the thing we are adding in to both sides. So far so good. So got b, got my factoring number with its sign, and the adding number. All right, so let's see. I combine the right-hand side. 9 minus 80 is a minus 71. This factors as something squared. Variable is x. My factoring number was minus 3. So you don't have to wonder how this thing factors. It will always factor as something squared and your factor number with its sign. That's the beauty of this adding number, is it makes this happen for us. All right, so by the square root property, I get x minus 3 is equal to plus or minus square root minus 71. So first off, split off the minus 1. That's going to give me the I part. So this part is I. And the square root of 71, you can ask yourself, well, could I take a 4 into it, a 9 into it? And the answer is no, we cannot break it down. And so I simply move the 3 to go on the right. And we get our two solutions as 3 plus or minus I square root 71. All right, question 9. In question 9, let's see. First problem we have is I'm looking at A. A is 2 and it's not 1. So I have to divide everything by A. Okay, so all terms by 2. Hopefully that doesn't make ugly fractions, but it can. All right, so that cancels. That's good. 16 over 2 is 8. Minus 60 over 2 is minus 30. So now we're all set. B is 8. B divided by 2, 8 over 2 is 4. That's my factor number. It's a plus 4. 4 squared is 16. That's my adding number. All right, so we're off and rolling. So let's see, add in the 16. 16 minus 30 is a minus 14. Left-hand side factors as something squared. Variable is p. My factor number was a plus 4. And so I get p plus 4 is plus or minus the square root of minus 14. So again, I'm breaking this down, square root of minus 14 as minus 1 times 14. And so I get square root of minus 1, square root of 14, and I get an I. Let's see, 14. Is 14 writable as 4 times something? No. 9 times something? No. And so we cannot simplify it. And so I get, when I bring the 4 to the right, I get minus 4 plus or minus I square root of 14. Okay, so let's take a look here. Question 10, we have something new. We want to solve this one by something called the quadratic formula. All right, well, to solve it by this formula, I need it in standard form because I'm going to need A, B, and C. All right, so standard form is in this format with a 0 on the right. So our problem, A is 1, B is minus 3, and C is minus 3. So the formula says that our answers are minus 1 times B plus or minus the square root of the B number squared minus, in parentheses, 4 times A times C, and the whole thing, all of it, over 2 times A. So not a small formula, not an easy one, but it will always give us the solutions. Now, two sources of difficulties. First, this minus 1 times B. If B is negative, then I would have a negative times a negative, making the front positive. The other part is keep this stuff in parentheses, because if C is negative, the product is negative, and I've got a minus a minus. So let's see for our problem. Minus 1 times B, well there's B, plus or minus B, here's B, B squared, minus 4 times A, which is 1, times C, which is minus 3. So let's see, I got a 3 here, plus or minus, minus 3 squared is 9. 4 times minus 3 is a minus 12. 9 minus a minus 12 is really 9 plus 12, which is 21. And we're done because we can't simplify this square root of 21. So my two answers are 3 plus square root 21 over 2 and 3 minus square root 21 over 2. Slowly and carefully. Now, this little piece under the radical in the quadratic formula, this b squared minus 4ac, is called the discriminant. Its purpose, its only purpose, is to predict the kinds of answers we're going to get. Why? Well, let's see. If that part calculates to be 0, then my answers are minus b plus or minus square root of 0 over 2. Well, that's 0. So this whole part's missing, which says I'm only going to get one real number answer. If this part calculates to be a positive number, well, then I've got the square root of a positive number, which is positive, and I'm going to get two real number answers because of this plus or minus. And if that part calculates to be negative, then I've got the square root of a negative number, which means I'm going to get out an I, and so I get two complex numbers. So if this discriminant is 0, positive, or negative, it can predict what kinds of answers we're going to get. So let's see. Question 11. Let's do this discriminant. So b squared minus 4ac. Where's b? B is the thing in front of the x, so minus 4 squared is 16. And then 4 times a times c, and I get 160. So I get 16 minus 160, which is a minus 144. So the important part is, did the calculation turn out to be 0, positive, or negative? And in this case, it turned out to be negative, and so that means I get two distinct, which means unique, complex numbers. Now they're writing in as non-real. Well, non-real is the same as complex. And finally, in our last question, we want to do the discriminant again. Now, looking at my problem, I'm noticing it looks a little fishy. It's not equal to 0. I can't get A, B, and C until I get a 0 on the right. So, move the 2 to the left, and now I'm in business. B squared. Well, there's B. That's a 7, so I get 49. 4 times A, what's A? A is the minus 6. C, because I moved this, is minus 2. So let's see. Minus 6 times minus 2 is a positive 12. 12 times 4 is 48. 49 minus 48 is 1. What does that mean? 1. Well, I don't care it's actually 1. What I care is it 0, positive or negative? And in this case, it's positive. Therefore, we get two distinct real number solutions. So a lot to digest in this section. Take your time, go slowly. We had the zero product property. We had the square root property. We had completing the square, which turned it into the square root property. We had the quadratic formula, and now we looked at the discriminant to be able to predict. Good luck, take your time. If you have problems, post them to the discussion board.